Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in today's video is problem solving on segment and its area. A circular segment is a region of a circle which is created by breaking apart from the rest of the circle through a secant or a chord. In other words, it is two equal halves that are divided by the circle's arc and connected through chord by the endpoints of the arc. Formulas to calculate the area of a segment of a circle is given on the board. Let me write it on the board. This is how a segment will look like, and the formula for the area of the segment in radians and degrees. So it depends upon the question that you're getting. In case if you're asked to give your answer in radians, you can use the first one. In case if you get the given information in degrees only, then you can use the second formula. Both will give you the same answer. According to this definition, the part of the circular region which is enclosed between a chord and the corresponding arc is known as the segment. The segment portraying a larger area is known as major segment, and the segment that is having a smaller area is called a minor segment. Hope you are familiar with this already. For more details about this major angle and minor angle, you can refer a previous video that is on segment of a circle and its area. Let us now move on to the examples. Here is an example where the central angle is given and the radius is given. So we are supposed to find the area of a segment given that the angle is 120 degrees and the radius is 6 cm. Formula is, let us plug in the theta and r value in this formula. So by substituting we can replace pi by 3.14. Replace theta by 120. So 6 square over 2, 3.14 over 180 degrees times 120 degrees minus sine 120. I'm getting 21.996. Please make sure that you include the units. Therefore, the area is 21.996 centimeter square. Hope you're clear with this example. So when the angle is given in degrees, we use this one. Now let us see one example where we'll be finding for radians. So for radians, in the question you can see the word central angle. For this example, we got the given information as angle. Here is your example number 2. Please read the question once. Find the area of the segment of a circle with central angle of 75 degrees and radius of 5 inches. Let us take down the given information first. Formula for this one is, so let us plug in the values given in this question in the formula. Replace r by 5, replace theta by 75. 5 square is 25 and sine theta is negative 0.3877. Now you can do the calculation part. So area for this problem is 942.34. Hope you are clear with this example. Let's move on to the next example. Please read the question. Find the area of the shaded region of the given circle that has a radius of 8 cm. So area of the segment can be calculated with the following formula. Area of a segment is nothing but area of the sector minus area of the triangle. I'm going to show you the solution in this way. First, let us find the area of the sector. Area of the sector is nothing but, plug in the theta and r value given in this question. Theta is 120 here and r is 8. So let us replace theta by 120 and r by 8 here. Replace pi by 3.14. So the area of the sector is 67 centimeter square. Am I right? Now we are supposed to find the area of the triangle. To find the area of the triangle, the 120 degree isosceles can be divided into two triangles. By dividing so you'll be getting two triangles with the angles 30, 60, 90. Am I right? So this triangle has been divided into two equal halves. 120 will be divided into 60 and 60. If the line is perpendicular to one side of the triangle, the angles formed here would be 90. If the two angles are 60 and 90, the third angle will be obviously 30. So 30, 60, 90 triangle. So the height would be just the half of this one, and this is a 2a root 3. So this is the ratio of the sides for 30, 60, 90 triangle. So using those properties, we got the sides. Radius is given as 8, half of the radius is 4, and the other side would be 4 root 3. Now let us use all this information to find the area of a triangle. So what is the formula to find the area of a triangle? Half times base into height. So for this entire triangle, what would be the base? If this is 4 root 3, this will also be 4 root 3. So totally it would be 8 root 3. Am I right? So the base is 8 root 3, height is 4. Now do the calculation. This will get cancelled out for 2. So 16 root 3. Convert everything into decimals. So you'll be getting 27.7 centimeter square. So far we got area of a sector and area of a triangle. Now let's find the area of the segment just by subtracting these two. Going back to the original formula for the segment area, sector is 67. So the final answer for this one would be 39.3 centimeter square. So you must be aware of the formula from where we derived the sector and triangle. Only if you are familiar with these steps you can solve depending upon the given equation. If one thing is not given, you can use any formula to find the other and get into the solution. So practice this example well. In the previous problem, the central angle is more than 100, more than 90 degrees. Now please see this. In this example, the central angle is 30, lesser than 90. So let us see how to solve this example. To solve for the area of the segment, we must first find the area of the sector and triangle to fulfill the given formula. Am I right? To find the area of the sector, theta is 30 and r is 4 in the given figure. Therefore, the area of the sector would be 4.2 centimeter square. To find the area of the triangle, we must first divide it into two right triangles. Am I right? This is the triangle. Let me divide it into two equal halves. By dividing, 30 will be 15, 15. Perpendicular, so 90, 90. What would be the third angle? Now we have a triangle with 15, 90, 75 degrees. For this triangle, we need to find the height of the triangle and base of the triangle to find the area. We can use sine trigonometric formula. Opposite by hypotenuse. Opposite is height and hypotenuse is 4. Plug in theta value. Cross multiplication. Now let's find the base. In the same way, opposite by hypotenuse. Theta would be 15 for this one. Cross multiply. Again cross multiply. So the base is 2.07. Plug in the base and height in this area formula to find the area of a triangle. So the area is 4. Subtract the area of the sector and area of the triangle to get the area of the segment. So the area of the segment is 0.2 centimeter the whole square. Hope you are clear with this example. Here is an example with quarter circle. How to find the area of the quarter circle? To find the area of a quarter circle, first remember that what the area of a circle is, pi r square. Since we are only interested in quarter of the circle, let's use the formula quarter of this area. Quarter is 1/4. Then plug in the radius so that your answer would be 9 square is 81. So 81 pi over 4. In case if you you're asked to give the answer in terms of numbers, you can replace pi by 3.14, or you can just leave your answer as 81 over 4 pi. Hope you're clear with this example. What will you do if you're asked to find the area of a semicircle? Same way, you have to just find the half of the area, 1 over 2 pi r square. Semicircle means half the circle. So you can just plug in the r value and find the area of a semicircle. The shaded area is 1/4 of the area of the circle. So based upon this question, I have drawn a figure. Here we are asked to find the area of the shaded region when the Cartesian plane plot a circle centered with the origin whose radius is 6. Please note that the segment should be 6, 0 and 0, 6. So this triangle should be an isosceles triangle. Am I right? So the shaded area is nothing but the 1/4 of the area of a circle, where you should minus the area of the isosceles right triangle with legs along the radius. What is the radius given for this one? The circle has the radius 6. So the area of the circle would be, just plug in the r value. R is 6, so 36 pi. So the part of the circle is in the first quadrant. So 36 pi over 4, like the previous example, which is 9 pi. If we subtract the area under the line connecting 6, 0 and 0, 6, we'll get the correct answer. So to find this area, recognize the geometry as a triangle. 2 points give you the base and height. So the area would be, base is 6, height is 6. So this one is 18. So the area of the segment is subtract the area of the quarter circle and the area of the triangle. So this would be, the area of the region is 9 pi minus 18. Am I right? That's it for this example. So in this video we discussed how to find the area of the segment when it is a quadrant, a semicircle, and if the central angle is more than 90 and lesser than 90. And we have also discussed how to find the area of a segment when just the information about the lengths are given. Hope you are clear with all the examples. In case if you have any query, please let me know. Have a great time ahead. See you in the next video.